I'm going to do a bunch of problems with you. For short, this is what I'm going to do. I'm going to do 2 and 10 and the whole FRQ, talk about some graph stuff that we need to talk about, then I'll open it up to any other questions that you guys may have. If you feel like you don't need this help, that is absolutely fine. You can choose to ignore me, no big deal. Well, kind of a big deal, I think, but you can ignore me if you want to. But just remember your classmates might want to hear, so you just need to stay quiet. But I'm going to give you guys some helpful tips and hints as we go, okay? And I'm making a recording of all this, so if there's something you miss or something, you can always go back and watch it, or if you just want like a refresher later. Okay. All right, so problem number 2 says to factor completely. Your final answer needs to be factors. And when it's multiple choice, you can see they're all in factored form, parentheses, okay? So you always want to factor out a GCF first, if there is one. And there is, okay? And you can try to use the chart method to factor this, but it's not factorable in that traditional method, okay? There's no way to use the chart to factor that. That's when you have to use quadratic formula. So I did put quadratic formula on the test for you, so you don't have to memorize it. But you should be able to pull out the A, B, and C. So A is 1, B is -4, C is 5. And then I gave you the formula. You can just plug the numbers in. So that's what I'm doing here. Okay. Once I plug everything in, I'm going to go to the radical. So underneath the radical, -4 squared is positive 16. I'm just going to use this as the workspace. And then -4 times 1 times 5 is -20. Okay? So then I go down. I have 4 plus or minus the square root of 16 minus 20 is -4 over 2. And then I can simplify that radical one step further. Square root of 4 is 2. A negative under the radical makes it 2i. And now the last step would be, if there's anything else that I can simplify, go ahead and do that. And I can. I can divide both my numerators by 2. And that would give me 2 plus or minus I. Okay, what we just found is that x equals 2 plus I and x equals 2 minus I. We just found 2 zeros, solutions, roots, whatever, okay? Remember, the directions say to put this in factored form. So all we're doing here, and this always gets people, I think I talked about that a little bit the other day, but I still haven't figured out what students are having such a hard time with it. But all I'm doing is bringing anything that's on the right-hand side over to the left-hand side. Following the rules you learned literally in pre-algebra, how do I move a 2 from right side to left side? I would subtract it, right? And I'm going to subtract it on that side. How would I move a positive I from the right side to left side? I would subtract it. So I would have -2 and minus I and nothing left on the right side. What we just created was a factor. It looks funny, but that's what it is. It's just a factor. It's everything brought to the other side. Same thing here. How would I bring a positive 2 to the other side? I would subtract it. How would I bring a negative or a minus I to the other side? I would add it, opposite. So I get x minus 2 plus I. I know one of the things that confuses people is that both of them have a -2 in them, and then they both have i's that are opposite signs. But that's because the 2's were the same signs when they were zeros. So when we do positive 2 to the other side, it becomes -2 or -2, okay? Don't forget that when at the very beginning of the problem, way up here, we factored an x out as well. Those are your 3 factors. Yeah?
How did we get the exchange over plus or minus sign?
Here? 4 divided by 2 is 2. 2i divided by 2 is I. Yeah. This This right here that you're asking about is a lazy way of writing that. It's the same thing, right? That 2 goes to both numerators. We just don't write it as 2 separate. Yeah. That's what I said I'm going to do. I'm going to do 2, 10, and the FRQ. Remember? Yeah, so I'm going to do that. Before I go to number 10, though, I want to show you a question that we haven't talked about since Friday, and you need to know how to factor it. So let me do this problem with you real quick. I would write it if you want to, or just watch. It's not from the review. It's just a problem type of problem that you need to know how to factor. Okay? This guy looks really similar to something that we would factor normally with a chart, right? Look at the slight difference. Instead of a 4 and a 2, we normally see a 2 and a 1 on our exponents on the variable. But we do factor it almost the same exact way. We ask ourselves what 2 numbers multiply to get 8 and add to get 6. So it's the same exact steps as if I were factoring this. And the numbers are 4 and 2. So if I were factoring this one, it would be x plus 4, x plus 2, right? The only difference here, 2 differences, instead of putting x here, like I would in this one, I would put x squared. Okay, but you can go one step further with this one. Again, we're used to seeing the difference of 2 squares. This is the sum. We could do x plus 2, x minus 2 with that. We're going to do the same thing with this guy. So we're breaking this into x plus 2, x minus 2. We just have to remember to put an I on the second term. That's the only difference. Square root of 4 is 2, and because of the plus sign, it made that number imaginary. Over here, we can do the same thing. It's going to be x plus something, x minus something. Now, the square root of 2 is a decimal, so I'm just going to put the square root of 2. I'm not going to write it as a decimal. And don't forget, it would have an I in the answer. So we learned that last Friday. We did like 1 or 2 problems like that, and that's the only time we've ever seen it. And we won't see it again after tomorrow. Okay, we don't really deal with imaginary numbers after this part of the course. There's a problem like that on the test tomorrow. Yes. It'll say, well, they could both say factor. This one said factor. I looked for a GCF first, and then I tried to do the chart method on this one. It doesn't work. There's no numbers that will work. So, yeah, if it doesn't work, then you have to do quadratic formula. If it does work, yay, it's a lot easier. Okay, I think. But you could, let's pretend that you didn't like this. You could do quadratic formula for this one and do the same exact steps. Quadratic formula works 100% of the time. Factoring only works sometimes. So that's why we have quadratic formula. It's a lot of work, but it always works. Okay? All right, let's go to number 10. I know that's another one that we had questions on. Number 10 is our last multiple choice question on the test, and it's the only one I require you to show work. Okay? And you'll have a ton of space to write, don't worry. And the directions here are to solve the polynomial. To solve a polynomial, we need our critical values. The critical values are your zeros. To get the zeros, we have to factor. To be able to factor, we have to get all of the terms on one side together. Okay? So all I'm going to do, this is exactly what we just did a minute ago. I need to get 3x and 6 to the other side of the inequality, the equal sign, whatever. That splits us into 2 sides. So those are both positive on the right side. To bring them to the other side, I make them negative. Same thing here. Those 2 are positive. I needed to bring them to the other side. I'm getting it in factored form. Well, first I'm getting it in standard form. Then we'll factor it. So when I bring those guys over to the other side, I will then have x to the third plus 2x squared, right? That's these 2, minus 3x minus 6. You want to make sure you're in standard form, which means everybody on one side together and your exponents on these sides. now that we have it in standard form, you say, okay, how do I find the critical values? Oh, I'm going to factor this. To factor, when you have 4 terms, we do 2 and 2. Do our grouping method. And then factor out the GCF. If we do it right, our parentheses should be the same. And they are. At this stage, we're in factored form. So now we can set each of them equal to 0, solve it to get our critical values. So you can show this work or not. It's up to you. I don't need to see this step. But when I set that equal to 0 and that equal to 0 and solve, I would get add 3, square root to both sides. And don't forget, when you take the square root of something, you get a plus and a minus. And the square root of 3 is a decimal, so I'm not going to write it. I'm going to leave it as a square root of 3. Okay. Same reason we left the 2 as a square root of 2 when I did this problem with you. Okay, because it was a decimal. I didn't leave the square root of 4 inside the radical because it was a 2. It wasn't a decimal. Okay. So I have plus or minus the square root of 3 and then negative 2. Now, the square root of 3, where is that on the number line? Well, I might have to put it in my calculator to figure that out. So I would do the square root of 3, and we just approximate that to 1.7, or negative 1.7 if it's the negative. Okay? And that's important just so I know where to put it on the number line. Okay? So now we make ourselves a big x-axis. And we put the 3 numbers on there. So negative 2 would be our smallest, then negative square root of 3, then the square root of 3. Again, remember, this is negative 1.7, this is 1.7, approximately. Then you find your test numbers. A number smaller than negative 2, any number you want, as long as it's smaller than negative 2, will work. In between negative 2 and negative 1.7, those are really close together, right? You would even round negative 1.7 up to a negative 2 or down to a negative 2. So your test number is going to be a decimal. So find something in between. Negative 1.8 would be smaller than negative 1.7. Negative 1.9, you could go out more decimal places. It really doesn't matter. It truly doesn't. Daniel, were you fast testing? Yeah, so it's starting to get out. In between a negative and a positive number, I always like to use 0. And then something greater than 1.7, how about 2? So those are my test numbers, okay? So I'm just going to put a little line under them so you know. Those are my test numbers. Now you have a choice. You can plug into either the original problem, which is what I did on my key. I plugged into the original problem. Or I think is easier to plug into the factored form, either one of these. I think this one is easier, so I'm going to do that now. But if you would prefer to plug into the original equation, you can do that. And I showed that work here, okay, on the key. So I'm going to use my calculator if I need it, and just start plugging my test numbers in. Now, we want our answers to be less than 0, right? Less than 0. So we want all, what, positives or negatives? Negatives. Less than 0, right? Right? Anything less than 0 is going to be a negative number. That is what will meet our criteria. So negative 3 squared is 9. 9 minus 3 is positive 6. You can put the answer, like you can put 6 there times whatever we get here, which would be negative 1, but you don't need to, because all we care about is getting a negative number. What that negative number is, it doesn't really matter. If you're negative, you are less than 0. Okay, so do the signs, do the actual problem. It's up to you. It doesn't matter. Negative 1.8 would need to be put in parentheses. Don't forget that, guys. You have to put negatives in parentheses when you square them. Okay? Bring your cursor down. Negative 1.8 squared minus 3. I don't care that it's a yucky decimal. All I care about is that it's positive. Sorry. And then negative 1.8 plus 2, when I put it there, I also get a positive answer. Positive times a positive is positive. That does not meet the criteria. We need only negatives. All right, 0 squared minus 3 would give me a negative. 0 plus 2 would give me a positive. A negative times a positive is negative. True. And then plug in 2. 2 squared is 4. 4 minus 3 is 1. 2 plus 2 is 4, which is positive. And a positive times a positive is positive. False. So the only parts of our solution are where we said true or made a smiley face, whatever you're using. Those are my solutions. Remember what I showed you that day? If you are using these symbols, or you're given those symbols, you have to use parentheses. The line underneath, you would use brackets. Negative infinity to negative 2. Negative square root of 3 to the square root of 3. Now listen, this multiple choice question is worth the same number of points as all the other multiple choice questions. So if you get to this question and you freeze and you start to panic and you realize time is ticking away and you haven't gotten to the FRQ yet, walk away from it, get that problem wrong, okay? It's worth it to not run out of time and get a whole bunch of things wrong, okay? If you're not prepared for this question, you're going to run out of time and you don't want to do that, okay? So please, please, please use your time wisely. Make a decision. Okay, maybe I'm going to save number 10 for very last because I'm not as confident about that. It's worth it to be able to do the FRQ, which I think you guys can handle, believe it or not, maybe more than this one, especially if you missed last Friday where we did several of these. Okay? All right, let's go to the FRQ, and I'll show you how to do that. And again, the FRQ will be a full sheet of paper, like a regular size piece of paper. I have the whole FRQs in a paper like this. You'll have lots of room, okay? All right, so first thing we should notice is in the directions, they give us 2 points, okay? There's 2 points in there that I like to label my graph with those points. That's up to you if you do or not, but it gives us point P is this, and it gives us point Q is this. Okay? Domain and range. Domain, range. You don't have to write out the whole word, or you can, doesn't matter. Okay? The domain of this graph is going to be all real numbers, also known as negative infinity to infinity, because yes, the arrows go down forever, but they also are going left and right forever. So we would say negative infinity to infinity. And remember, always on infinity symbols, we put parentheses. Okay? The range, you'll hear me talk about flashbacks to you guys. I have flashbacks all the time of when I've graphed a problem like this in the past, and I'll remember, oh my gosh, this is a problem a lot of students get wrong. Range, which is a pretty simple concept, is something that people get wrong on this test all the time. Here's why. You make the mistake of not realizing your range has to be in order from least to greatest, okay? Range are your y values, okay? But just like our x values, we always do least to greatest or left to right. We read our y-axis, least to greatest, but it's from bottom to top, okay? So those arrows are pointing down forever. That means we start at negative infinity. And then we go up to what y value? What's our highest y value that we're going to reach on this graph? What is it? 12.4. The other thing that people mess up on is, do I put parentheses or a bracket on this one? Bracket, yes, Evan, a bracket, because 12.4 is included in the graph. It is an actual y value on this graph. It's right here. Remember we labeled it? Bracket means it's included. It's part of the answer. Okay? So that's the way, if this was your test question, your range has to look like that. If you put 12.4 first, it's wrong. If you use parentheses around the 12.4, it's wrong. Okay? So that's important. It's not a difficult concept, right? The range, we understand what that means. What are the y values on the graph? But the notation in this class is very important besides just knowing the concepts, okay? All right, points of inflection, POIs, are where your graph changes concavity, okay? So if you look, we're concave down, and then somewhere over here, I don't know where, but let's just call it right there. Somewhere around there, we change to concave up, right? And then somewhere around here, I'm not sure exactly where, right? I'm changing from concave up to concave down. We have 2 points of inflection. To find those approximate points, we use the midpoint formula. So we take the points that's on either side of the approximated POI, and we do the midpoint formula. And I get the question, do I have to know the formula? Yes, you have to know the formula. Midpoint is easy, guys. Add your x's divided by 2, add your y's divided by 2. You do it all in your calculator. So to find this first one, I'm using -3,0, and this point down here, -1.2. And so you're just going to add your x's together. It doesn't matter which one you put first. The operation is addition. If I asked you what is 2 plus 3, would it be the same as 3 plus 2? Of course. So it doesn't matter which one you call the first point, which one you call the second point. So add my x's, divide by 2, add my y's, divide by 2. You're just finding the average in between those two, the midpoint. Put it in your calculator and get your answer. Where's my key? Get your answer of -2.1 is my x answer, and -0.9 is my y value. So I'm just putting this in my calculator and getting my answers. So that's this guy right here. And you don't have to label your graph. I'm just doing it to make a point. Okay, so that's that POI. Okay, then we have another one, as we said, in between point P and point Q. So I'm just using those x values now. So x would be 2.6 plus -1.2 divided by 2. Y would be 12.4 plus -1.8 divided by 2. Do all that math in your calculator, you'll get 0.753. Okay, I'm not going to write it again. That's that point right there. And again, you don't have to label the graph. I'm just showing you what I do. Those are your points of inflection, midpoint. Okay, next question, absolute extrema. Absolute and global mean the same thing. It means the absolute, the highest and or the lowest. You could have one of each. You could have just one. You could even have none. You could say there are none, okay? But in this graph, I think you guys would agree that point Q is our absolute what? Is it a max or a min? Max, right? Because it's at the top of the graph. Make sure you tell me, is it a max or a min? Don't just write the answer. I need to know that you know that's a max. So the absolute max is 12.4 at x equals 2.6. That was a point they gave us, right? That was given to us. We are just renaming it here. Where is f of x increasing and decreasing? So when we're talking about the graph of f of x going up or down, or increasing or decreasing, it literally means where's the graph going up and where is it going down. And don't forget, intervals means x values. Okay, it's got to be the x values. So let's start with increasing, then we'll do decreasing. So we're going up from negative infinity until negative 3. And you can use brackets or parentheses here. It doesn't matter. As long as on the infinity symbols, you always use parentheses. But the negative 3 can have a bracket or a parentheses. It doesn't matter. Okay? And we are also increasing from negative 1.2 to 2.6, right? The x values, this whole section right here. And you can use the union symbol. You could put a comma. It doesn't matter. Whoops. Can't talk and do anything at the same time. Negative 1.2 to 2.6. Least to greatest, always. Decreasing from here to here. If you look at my pen, that's negative 3 to negative 1.2. And then we're also decreasing from 2.6. Be careful. Another flashback moment. People getting that wrong. What would that answer be right there? No. You don't have to be sorry. It's okay to make a mistake. Infinity. What do you think, Evan? What do you think the common mistake is there? Anybody know what I was going to say? Negative infinity. Because look, you're saying we're talking about decreasing. So your eyes are going, oh, I'm going down. Where am I going down? What's down? Down is negative infinity, right? But we don't care what the y's are doing when it asks you the intervals. It's saying, what are the x's doing while I'm going down? Do you see that, Remy? So as we go down, we're also going to the right forever. It's going to keep going down forever, which is to the right forever, okay? And the last one, where are we concave down? For concavity, we have to use parentheses. That would be marked wrong if you use brackets. Lots of little things that we're nitpicky about in calculus. Okay, so concave down, we have two sections, and I'm here and here. We need our POIs to name this, because where the POIs are is where the concavity changes. So for example, this concave down is negative infinity, right, to the left, and then it stops being concave down at our POI, which is negative 2.1. And union or a comma is fine. And then, again, from this POI, which is 0.7, to positive of infinity. 0.7. So in here is where you can earn partial credit. Each of these is worth a varying amount of points. So I really do look for any place I can give you the points, but there's no tricking you guys. This is what your FRQ is going to look like, just going to be a different graph with different points, but the same questions, okay? So that's why my practice tests or reviews, whatever you want to call them, are super, super, super valuable. They are giving you lots of good info about what's on the test. Now, in a minute, I will offer up you guys to ask me questions about anything else, but I want to show you guys, sorry, you still writing? Really? Sorry. I want to show you guys something I did with the other two classes, and I got some good feedback about. So let me show you. I printed just a bunch of graphs, and we're just going to go over a few of them. And I want to I feel like this is going to help you guys really see some of the vocab and how it's different. So you don't need to write anything. If you feel like you want to see this again, it's in the video. But I want to talk about all the different things we can say about these graphs. Remember increasing and decreasing and positives and negatives. There's so many different things that we can say about these graphs. So we're going to do A, B, C all together, at one time. So what I want to first say, we're going to call A, B, and C, the name is f of x. So I'll be referring to these graphs, A, B, and C, as f of x. Let's just talk about concavity. What would you guys say this one is? Concave up or down? Up. Okay, that's concave up. That one's concave up, that one's concave up, right? Holds water, but it's a broken bowl. There's a piece of it missing. But what we have would make a bowl that holds water. So all three of them are concave up. Let's talk about the graph first. Is my graph, would you say my graph is increasing or decreasing? Decreasing. As we go left to right, we are decreasing. F of x. How about f of x here? Are we increasing or decreasing? Increasing. As we go left to right, we're increasing. And this one would be decreasing. Okay? So that's just the graph. What's the graph doing? Is it going down left to right or up left to right? That's f of x increasing or decreasing. Now, we haven't talked about this one in a while. Is f of x positive or negative here? Positive or negative? It's positive. What that means is above the x-axis. All my points, my y values, my f of x are positive. Same thing here, and happens to be the same thing here. All of the graphs are above the x-axis. F of x is positive. Now let's talk about the rate of change. The rate or rate of change. I'm just going to say rate. The rate, so this is the one everyone gets wrong, not everyone, but is the rate increasing or decreasing on this one? Would you say? Increasing. You want to say decreasing. The graph is decreasing, but remember, concave up means the rate of change is increasing. So for all three of these, the rate is increasing. That right there is a big disconnect for most people. So good job, Sam. And I want to remind you, when you're concave up, even though these are negative slopes, like that's the graph we're looking at right there, these are all negative slopes, but negative numbers can increase and decrease. Think about it. On the number line, if you go to the right, your numbers are getting bigger. If you go to the left, they're getting smaller. So these numbers are actually increasing in negative land, okay? Until you get to 0, then they start increasing into positive land, okay? So concave up has increasing rates of change. How about this? Is the rate positive or negative? Is the rate positive or negative here? Think about if you look at the end behavior, this is like a line with a negative slope. If your graph, if the f of x is decreasing, your rate is negative. All your slopes are going to be negative on this part. Notice it's not the complete U, because then it changes to something else. But just on this graph, my rate is negative. My rate would be positive here. We're increasing. My rate would be negative here because we're decreasing. Okay? So let's look at this next one. All three of these are concave down. Right? The water would fall out. Okay? So let's talk about, we'll call him these g of x. G of x, is this graph increasing or decreasing? Decreasing, because you're going left to right. Remember, and that's the confusing part about these. We're using the same words, increasing and decreasing, positive and negative. They mean two different things, whether we're talking about the graph, g of x, or if we're talking about the rate of change of g of x. That's what's confusing. We have to separate those ideas. So the graph is decreasing here because it's just going down left to right. This one would be increasing because it's going up. This one would be what? Decreasing, right? Is the graph negative or positive here? It's negative, right, Remy? Because it's below the x-axis. Same with this one, right? And this one would be positive. Now we're assuming it's not going to cross over, just what we see, okay? We're just kind of making this really simple. Now let's talk about the rate. Is the rate of change increasing or decreasing here? Remember, rate increasing or decreasing has to do with concavity. All three of these have a decreasing rate. Even this one. It goes against what you think. But if you're concave down, your rate is decreasing. And then, is it positive or negative? Is the rate going to be positive or negative here? Negative. I'm just being lazy now. Rate would be positive. Rate would be yes. Did that help anyone kind of seeing those pictures like that? I'm going to tell myself to do this next year when I teach this, because I think when you see a whole bunch of them next to each other and kind of talk about it like that, it helps. Yeah. Yep. I'm going to open it up to any questions on the review at this point. Remy, what question? Oh, back to Ted? Yeah. All right. What did you have a question on? These are the numbers I plugged in, my test values. I'm testing those values to see if they're positive or negative when I plug in. Okay, did you put -3 in parentheses? -3 squared, bring my cursor down, -3 gives me a +6. Yep, that's what I wrote here, positive. Okay, then -3 plus 2 is negative. So a positive times a negative is negative. Did it just click for you? Okay. Okay, no problem. What else? Say it again. After school? Okay, sure, yeah. You can get partial credit for it now. Yes, here you go, sweetie. That's good enough for me. Thank you. Well, about near the only I was going to ring in 5 minutes. Yeah, that's what we're doing. Miss Shacken said you went and got help from her. Yeah. Good.